Fire, help! We need some help over here. Where's Pythagoras when you need him? Haha, so the ladder, a building, fire, you will need Pythagorean Theorem. Application of the Pythagorean Theorem.
Problems are taken from New York Crosswalk Coach Plus from Triumph Learning.
Example number 1. A rectangular prism is 4 feet long, 3 feet wide, and 12 feet high. What is the length of the diagonal of the prism? This is a three-dimensional figure, a 3D figure, and I want to know the diagonal. Take note, this is not a 2D, but a 3D. So this is the diagonal. From one vertex E to the other vertex C, I want to know the length of that diagonal. But you can consider it as the hypotenuse. But this cannot be the legs. See that? It's crooked. This is not a two-dimensional figure. Therefore, I need an imaginary line at the bottom. This will be one leg. And then the one in blue, this is another leg. So if I know this leg, basically you know that's also 12 feet. This one, the hypotenuse, you don't know. The leg at the bottom, I don't know. So, leg at the bottom. Let's start with this. And we know that's going to form a 90-degree angle. It is a right triangle. So, at the bottom, we need that line below. We solve for the diagonal at the base, the length of EG. EG. That's the red line. That's the red line. So, to solve for that, we know that that is the hypotenuse, and that 3 feet and that 4 feet also forms a right triangle. Those are the legs. So once I know the dimension of two legs, I can solve for the hypotenuse. Write down your formula. Plug in 3 for that leg, 4 for that leg. So that's going to be 9 plus 16. Add them up. It's going to be 25. Square root on the left, square root on the right, and we get a value of 5 feet. So the bottom length is 5 feet. That is what we solved for. Since we already know 5 feet, and this leg is 12 feet as well. See that? Now I can solve for the hypotenuse given the two legs. So I want to solve for side EC. EC. And how do I do that? I use my Pythagorean theorem. A is my 5. B is my 12. 5 times 5, 25. 12 times 12 is 144. Add them up, it is 169. Square root on the left, square root on the right. That cancels out. C is finally alone. And C is exactly 13 feet. So, this diagonal is 13 feet. Problem number 2. A team of archaeologists fence off an ancient ruin they are exploring. They created a grid to represent what they are so they could label the locations of several artifacts. For example, they found a pot. This is a pot at point P. That's point P. They found a picture at point R. For each unit on the grid represents 2 meters. Approximately how many meters apart were the picture and the pot found? How far away is this from there? But take note, each square has a unit of 2. So let's look at this. And let's look at that. So those are both legs. The distance between them is the hypotenuse. So what do? The legs are given. So we have not 1, 2, 3, 4, 5, 6, but 12. Take note, it's 12, not 6, because 16 minus 4 is a 12. Got it? And for each unit, there's an interval of 2. So we're solving for the hypotenuse. To solve for the hypotenuse, again, we plug in the value of the legs. 12 is over there, 4 is over there. These two could interchange. So 4 times 4 is 16, 12 times 12 is 144, Add them up, you'll get 160. Square root on the left and square root on the right, you're going to get 12.649 non-terminating decimal. So you could just round it to the nearest tens. I could say 12.6 feet. This is 12.6 feet. Problem number 3. Determine whether or not parallelogram ABCD is a rectangle. So ABCD. It looks like a rectangle, but we need to prove it. Okay? But you have to know a prior knowledge. Okay, new input. For a parallelogram to be a rectangle, the diagonals should be congruent. What do we mean by that? Meaning AC, this AC, that's called a diagonal. And there's another diagonal, which is BD. BD is this one. So to prove that they are really a rectangle, these two diagonals should be congruent, meaning they have the same size and the same length. So let's prove it then. Let's start with this diagonal AC. All right? To solve for AC, it's difficult to count this one and that one because they're not exactly a horizontal or a vertical line. So what do? You use the coordinates. So you are a negative 6, 2. You are a 4, negative 3. So let's use x1, y1, x2, y2. Remember that. Or you could reverse it. So let's write down that formula. And then it is translated into the distance formula. Remember distance formula? So let's plug it in. 2 goes here. Negative 3 goes there. Negative 6 goes here. 4 goes there. So I subtract. And remember, keep change opposite. That translates to 2 plus 3, negative 6 plus negative 4. So let's add them up. 5 squared, negative 10 squared. 5 times 5 is 25. 10 times 10 is 100. Add them up, 125. And the square root of 125 is 11.180339, non-terminating. Now let's look at the other diagonal. That is BD. Again, get the coordinates, negative 2, 5. Get the coordinates 0, negative 6. So, plug it in, your distance formula. 5 minus negative 6, negative 2 minus 0. Okay? Keep change opposite. That's 5 plus 6, negative 2 plus 0. Add them up, 11 squared, negative 2 squared. 11 times 11 is 121. Negative 2 times negative 2 is 4. Add them up, you get square root of 125. Wow, same as the other one. So, the square root of 125 is also 11.18033, non-terminating. So, we got the value of AC and the value of BD. A while ago, we solved for this and we got 11.1803339. And a while ago, we got this also 11.1803339. They are the same. Check this out. Since they are congruent, we have proven that it is a rectangle. Two diagonals are congruent. It is surely a rectangle. Next, problem number 4. Simon leans a 20 feet ladder against the side of this house so that the base of the ladder is 5 feet from the house. 5 feet from the house, this is the ladder. Just like the previous example, let's say there's a fire. Okay, we want to know how far away is this point from that point. About how high up is the side of the house does the ladder reach? Round your answer to the nearest tenth of a foot. Okay, this to that is what we want to know. Focus on this right triangle. So whenever something leans on a perpendicular wall, it always forms a right triangle. Remember that. So focus on the hypotenuse. We already know. This is another leg, which is 5 feet. Therefore, that part is what we want to know. It is not a hypotenuse. It is now the leg, a missing leg. So let's just zoom on that right triangle. And we could write down our Pythagorean theorem once again. Since we already know the hypotenuse, I substitute it here for C, 20. I already know one of the leg, I plug it in here, 4. So the base is missing. Just square it to 20 squared is 400. 4 squared is 16. This I don't know. I want to get rid of 16. Subtract 16 on both sides. 400 minus 16 is 384. That cancels out. B squared goes down. Square root on the left, square root on the right. And you'll have B is equal to 19.59. Round to the nearest tens. This 9 will affect the 5. That makes it 19.6 feet. Okay, got it? Good.